Why are synchronous condensers crucial for grid stability? Imagine a power grid as a busy highway where cars representing electricity. To keep traffic flowing smoothly, the road needs to stay level and steady. That's where synchronous condensers come into play. These machines are like the traffic controllers that keep everything balanced and safe. They don't produce electricity like generators do, but they do a lot to support the system's health. One of their main jobs is to supply reactive power. Reactive power is essential for keeping voltage levels steady across the transmission and distribution lines. Without enough reactive power, voltage can drop too low or rise too high, which can damage equipment or cause blackouts. Synchronous condensers can both produce and absorb reactive power, helping to keep the voltage just right, even when the load changes suddenly. Another key role they perform is providing system inertia. Inertia is the ability of rotating parts in machines to resist sudden changes in frequency. Traditional power plants like coal or gas turbines naturally provide inertia because their large spinning parts store kinetic energy. But renewable energy sources like wind and solar don't have these spinning parts, making the grid more vulnerable to quick frequency swings. Synchronous condensers act as spinning masses, helping slow down these frequency changes and keep the system stable. They also boost short-circuit power, which is the current available during faults or short circuits. This is important because protective devices need enough fault current to detect problems quickly and shut down the faulty section. Renewable sources like solar and wind usually provide limited short-circuit current, so adding synchronous condensers ensures protection systems work properly. In addition, these machines can help absorb harmonics caused by power electronic devices used in solar and wind farms. This improves power quality and reduces the risk of equipment malfunction. They are often installed in areas with high renewable energy penetration, on long transmission lines, or where voltage stability is a concern. Sometimes, existing generators are converted into synchronous condensers, or they are equipped with flywheels to increase inertia. Their ability to respond quickly, handle overloads, and continuously adjust reactive power makes them vital for modern power systems. They help maintain voltage and frequency stability, support protection systems, and keep the grid reliable as more renewable energy sources are integrated. Without these machines, keeping the power grid stable would be much more challenging, especially with the shift toward cleaner energy options.